Hi, my name's David, and I want to talk today about interactivity and multimedia in the mathematics classroom. I want to start first with the notion that we need to change our curriculum. It needs a pretty serious change from math computations being at the center of the curriculum and with maybe a small connection to the real world and sort of some artificially designed problems, to the real world being at the center, and the real world here being pretty broadly defined as sort of things which students find engaging and interesting. So we don't have to necessarily be talking about consumer mathematics here. But then looking to see how that's connected to the mathematics. So this way students see that mathematics is about the real world and about ideas and not about the computations. And this also makes it easier to connect to the subjects. And I want people to understand that the mathematics itself is a process of asking ideas and sharing those ideas with other people in possibly formal language, and then trying to explore and get to those ideas in more in depth. It's like trying to find pieces in a puzzle. And I'd like a lot more flexibility in what's taught in schools. I'd like to see schools able to teach multiple tracks of different ideas, different mathematics, and a lot of mathematics which unfortunately doesn't get to see its way into most schools. These lists here are just a sample. I mean, there's much more mathematics out there that would be very interesting. I want people to see that mathematics is about storytelling. It's about taking things which interest us and figuring out and playing with them and trying to see what's going on. And that you can go around in your life and find examples of mathematics all over the place. We've got a lot of projects which sort of are ways to share mathematics from the real world that people see every day. And it's worth talking about what we do by hand in mathematics versus what happens with the machine. That the invention of paper is this terrific way to record ideas and share them with other people, but that technology is changing and that we need to consider what ways computers would be useful in mathematics education. Here's a little story about a friend of mine. He's an oceanographer, and I asked him, how do you use mathematics in your job? And he said, I don't really. Hardly ever. The computer does all the math for me. So I asked him what he actually does, and he says that he goes out there and he collects data, and he analyzes it, and he tries to figure out what's going on, and then he produces models of that data and turns those into differential equations, which he then substitutes into his computer, since that's the most efficient way to work on it. And then he gets an answer and analyzes it, and he's got sort of his result. And what I think is kind of interesting is that he doesn't realize that that's mathematics. And what we see here is a picture where he proves that stations 1 and 2 provide enough information that you don't need station 3. So he's taken a problem in context and he's solved it. He's found the puzzle. He's found the piece that makes it work. And then his solution itself is just a representation. It's not necessarily an ideal solution or the only solution. It's just a way of doing it. And here's somebody who's using a computer for one portion of his mathematics. And I think that it's a mistake to think that he hasn't done mathematics just because the computation step's been done by a computer. And I want to be clear here. I don't think that programmed instruction or computer-assisted instruction is really using computers in math. It's really just a delivery method. So maybe it's got some utility. I don't know. But it's certainly not what I'm looking for the direction of mathematics education. I like the idea that tools like Wolfram Alpha let you sort of, on the fly, wherever you are, learn about mathematics and to do mathematical computations, and that this tool is free to use. I like that you have other tools which allow you to sort of create complicated representations and scripts to run to get to mathematics, and that you can download some of those tools and use them on your own computer, and some of them are open source and free for anybody who wants to use them. And that some of those tools are really powerful, that you can compute things that you couldn't possibly do on a handheld calculator, that the computer has really got way more power than these little devices we give kids. And this isn't something you can do on a phone very easily. And that you can use mathematics to create visualizations. And maybe it's you as a teacher creating visualizations for your students, and maybe it's visualizations that the students create. In any case, these visualizations are kind of like mini stories telling a little piece of mathematics, and I think it's absolutely valuable to be able to share them. They're interactive, and they do more to present what you're trying to convey than you can do with pencil and paper. I like the idea of taking a worksheet, the thing on the left, and The thing on the right is basically the same idea. What you do is you give the students a picture of some sort, if they create the picture themselves, sort of basically recognizing this thing they're looking at has fantastic representation of math in it, which I think is awesome. I had a student who drew a robot, and I asked him to find all the pictures of the line, all the equations of the lines in the robot, and he turned around and he said, this is a pretty complicated robot. And I said, yeah, you decide if you want to continue. You can always simplify it. He said, no, I like my robot. And he went off and he came back the following weekend, and he had done the equations of lines, the domain, the range, and an explanation for 187 lines. And I can't imagine any student doing a worksheet for that long. And I like the idea that you can take sort of things like symmetry and turn them into activities where you can see the reflection symmetry. It's quite fascinating. And you can take, and this is from John Scammell, you can take, celebrities in the world and go and see and find out, does the golden ratio really exist? So this is a story too, right? You're looking at the golden ratio and you're trying to ask yourself, is this story about the golden ratio I've heard, where it represents beauty, really true? Is this how we see beauty? You can use it to collect data. You can do student tutorials. So here's one.
So today we're going to be learning what are lines of best fit. Alright, so here we have a scatter plot graph of length of eyebrows versus amount of text.
So here's a student who's created a tutorial to explain something, and in fact, MathTrain.tv has got hundreds of these tutorials created by 6th graders. I think the idea of students explaining things is really powerful, and we remember that people remember more what they explained than what they learned or what they read. And video word problems. So these are very much stories. Let's check this one out.
NF has eaten 1 large extra cheeseburger, 2 lasagnas, 3 plates of sushi, 2 pints of Haagen-Dazs ice cream, 2 gallons of Coke, and 1 gallon of water. He is currently chewing on 4 packs of Chiclets bubblegum.
I eaten a lot. Now I want to swim. Holy crap!
Holy crap! He said holy crap! Oh, am I glad? Who can say NF in Thai?
Hi!
Now, let's there be protractors.
I got 63 degrees. I got 761 degrees.
The sides of the pool are 250 meters and 500 meters. The pool is rectangular, and the standing positions are as follows in the diagram. Leg swims at 1.1 meters per second, and wind swims at 1.12 meters.
So can you see how that changes the story problem? That changes word problems from things that students see and don't really get to things they create? It's pretty cool. And I like the idea of representations that, things like fractals, for example, that, students almost never get to see the beauty of the mathematics. And this is amazing, really interesting stuff that they can explore. And creating models, so actually building models of things that they can't build themselves, and then maybe you have them find the cost of the model. Maybe you have them to figure out how much it would take to build this. And then we can look at programming, things like Scratch. So learning how to make something move it's very mathematical, and for many people it's a way to access variables and understand what's going on in algebra. Solving real problems. I had students who I said, I need a cell phone. I don't know what plan I should choose. So they went off and they graph some data and they look at it and they say, yeah, here you go. And I said, I don't know, I can't read that. Can you explain what that means? And then they recognize that what they really should be graphing is maybe the optimal solution, and that the optimal solution isn't a single number. And then I think, well, maybe we should get rid of some of the noise. And so now I've got my cost per month versus minutes used in a month, and I can look at this and see, depending on how many minutes I'm probably going to use in a month, which cell phone plan is the best. Here's some image credits from before. Thank you very much.